Hi, my name is Sam. I'm with the Economics Tuning Department, and today I'm going to go over rational constraint choice. This builds off my previous video about preference structuring. So now what I'm going to proceed to do is connect how preferences are made by a consumer, and then given a budget set, how we can find an optimal choice given a budget set. So what I defined here is prices times a good plus prices times another good, which is our total income. So P1 X1 plus P2 X2 is our options under a given income M. So what we're continue to do is connect this on a graph. So right here we have the slope of the budget set, and then right here we have a tangency with the indifference curve. So an indifference curve is a set of consumer bundles which is indifferent to each other, and at a tangency between the budget set and the indifference curve, that's where we have an optimal choice. So right here, X1 star and X2 star is the most preferred bundle given the constraint choice. So if you look here, this blue inner quadrant right here is the most is affordable bundles. But given that we have a budget set up here and the indifference curve has a tangency right there, that's how we would choose our consumption bundle between the indifference curve and the budget set. And then in this outer region, we have more preferred bundles, but given that our budget set is on this line right here, we can't choose any of these consumption bundles because it's outside of our budget constraint. So X1 star and X2 star have two key conditions to satisfy a tangency with our budget constraint and the indifference curve. So A is budget set is exhausted. So at the optimal bundle, between the prices of X1 plus the prices of X2, you've used all your income. So if you have $100, you've spent it, given your preferences, all of your $100 on those two goods. And then B states that the slope of the budget constraint, which is a negative price ratio, so a negative P1 over P2, that's how the slope of the budget set works. It's a negative slope down, and the slope of the indifference curve have a tangency. So in my previous graph, I showed that there's a single point at which both X1 star and X2 star connect with the budget set. So now to add some clarity to how this works is we're going to suppose the consumer has Cobb-Douglas preferences, which is one of the most common preference structuring in microeconomics. So how the utility function works is the utility of good 1 and good 2. So it's X1 alpha, X2 beta. Now these alpha and betas, these are just random variables we give for X1 and X2, so we don't have to give any numeric value. It's very well possible that in some of the courses you could have X1 to the negative half, X2 to the half, any sort of value like that. I just write it for terms of generality. So now we're going to proceed by doing some calculus. So we do have a series of videos on calculus review in case you need a refresher or any sort of that material. So the process to to do the partial derivatives, so we take the partial derivatives of X1 and X2. So up here we have the marginal utility of good 1, which is the partial derivative of X1 with respect to the utility function. So it's going to be alpha times X1, alpha minus 1, X2 beta. And then the same process goes down here. So we have the marginal utility of good 2, which is going to be beta times X1 alpha, X2 beta minus 1. So now we're going to continue by dividing these by each other, which is just going to give us our ratio of how we substitute each good. So this is, we divide the marginal utility of good 1 by the marginal utility of good 2, and by simplifying we have these two, and then it simplifies down to negative alpha X2 over beta X1. So for more clarity on this term right here, given our preference structuring, this is how we substitute each of our goods based on a random scalar. So all alpha and beta are here is assigning weights to how we choose good 1 and good 2. So based on the calculus here, you could substitute any sort of number to have a ratio between how we substitute each good. But that's all this term means right here, is it's a ratio between the marginal utility of good 1 and the marginal utility of good 2. So now to continue this, we're going to connect our previous solution, the ratio of how you substitute each good, with our budget constraint. So if you look here, we have X1 star and X2 star. This is the tangency between our negative price ratio, how the price of each good is substituted. And now right here, we have a single tangency. So this means that at this point, this is the optimal solution given our constraint choice, which is all about what this topic is about. So now what we're going to do is set the our previous solution equal to our price ratio. We're going to cross multiply. So then we get negative beta P1 X1 star over negative alpha P2 equals negative alpha X2 star P2 over negative alpha P2 star. And then we're going to divide by negative alpha P2 to isolate X2 star. And then it'll be equal to X2 star equals beta P1 over alpha P2. So what I did here was isolate one of the x's so that we can have it in one of the optimal solutions in terms of our scalars, beta and alpha, our price ratio, P1 and P2, times the second optimal solution. And you could very well easily do this for X1 star as well, where you would just set equal, do the same process, cross multiply, and then divide by the prices and the weights, and then have it set equal to, it would be X1 star equals the price ratio of the weights, and then times X2 star. And what all this means is exactly what I said previously, is that this is a tangency between the price ratio and the optimal solutions for our budget set. So if you have any more questions, either come visit the Economics Student Department or see your professor.